All right, today we're going to dive into this invisible force that makes our motors spin and our generators hum, the magnetic circuit. It's literally the secret engine inside so much of our technology, and we're about to pull back the curtain and see exactly how it all works. Let's get into it. I mean, have you ever really stopped to think about it? How does the electricity coming out of a wall socket actually become the spinning blades of a fan or the powerful force that pushes an electric car forward? Well, it turns out there's this critical, kind of invisible bridge that makes it all happen, and that's what we're here to figure out. And this bridge, oh, it's absolutely everywhere. Think about it. The motors in your kitchen, the giant generators creating our power, the tiny little relays that switch circuits on and off, and the actuators that make super precise movements, they are all running on the exact same fundamental principle to turn electricity into motion. Okay, so let's pull back the curtain and meet this invisible engine. It's time to get formally introduced to the magnetic circuit. So what is a magnetic circuit? At its core, it's just a closed loop that's designed to guide a magnetic field. It's got three key parts: a core, which is usually made of iron because it's great at carrying the field, an exciting coil, which is where we feed in the electrical energy, and an air gap. And trust me, this little gap is way more important than it looks. Okay, and here's the best way to think about it. It's a fantastic analogy. In an electrical circuit, right, you have voltage, that's the push, and you have current, that's the flow. Simple enough. Well, a magnetic circuit, it works the exact same way. The push is called magnomotive force, or MMF, and the flow is called magnetic flux. It's the same idea, just with magnetic forces instead of electrical ones. All right, so we've got a push and a flow, but how does that actually turn into, work? How does that convert energy? Let's trace the path all the way from the electrical input to the mechanical output. Let's walk through this step by step. First, we pump electricity into that coil. Boom. That creates our push, the MMF. That MMF then drives the magnetic flow, the flux, all the way through the iron core. For just a split second, that magnetic field holds on to the energy, kind of like charging up a tiny battery. And then, poof, that stored energy gets released as real physical force or torque. And just like that, electricity becomes motion. So, you see? The magnetic circuit isn't just some passive path for the field. No way. It is the active bridge that lets energy make that incredible leap from the electrical world to the mechanical world. Without that bridge, the energy just couldn't make the jump. Okay, now for what I think is the most fascinating, kind of mind-bending part of this whole thing. Where does the real magic happen? You might think it's deep inside the iron core, but the secret, it actually lies in empty space. This quote just nails it. The most important part of the circuit is the part that isn't there. So what on earth are we talking about? We're talking about that little gap we mentioned before, the air gap. Yeah, that little slice of empty space is absolutely crucial. I mean, first off, you obviously need a gap for things to actually move, right? Like the rotor spinning inside a motor. But here's the kicker. The air gap is where most of that magnetic energy gets stored right before it becomes force. The iron core is the highway, but the gap is the destination where all the energy piles up. And the size of that gap, it changes everything. A tiny gap means you have very little magnetic resistance. Engineers call this reluctance. Just think of it like this. The magnetic field is lazy. It wants to take the easiest path possible, and that's across the smallest gap. That desire to snap the gap shut is what creates a super powerful physical force. A bigger gap means more reluctance and a much weaker force. Okay, so understanding all this stuff isn't just for, a test. It's absolutely crucial for designing pretty much every electromechanical device we rely on. So let's talk about why this circuit matters so much in the real world. When engineers are designing these machines, they are totally obsessed with the magnetic circuit. Their whole job is to guide that flux exactly where it needs to go, slash energy losses from annoying things like eddy currents, and just generally make the machine as efficient and stable as possible. A killer magnetic circuit is the secret sauce to a high-performance machine. And believe me, its applications are everywhere. In a motor, it's creating that spinning field that gives you torque. In a generator, it's doing the complete opposite, turning motion back into electricity. And hey, even in a transformer where nothing is moving, the magnetic circuit is the whole reason you can transfer energy from one coil to another. It really is a universal piece of the puzzle. So yeah, it is absolutely no exaggeration to call magnetic circuits the heart of these systems. That's exactly what they are. They are the central beating heart that enables all this energy conversion, pumping that magnetic flux through the whole system to bring it roaring to life. So there you have it. These incredible, invisible engines are the foundation of so much of our modern world. And that leaves us with a really exciting question to think about. If magnetic circuits are the heart of all the machines we have today, what amazing new devices will they power up for us tomorrow?